Hello, welcome to the video. Uh, in this in this video, we'll be looking at section 6.4, where we're going to focus on transformations of exponential and logarithmic functions. So we're going to figure out how can we transform the graphs of exponential and logarithmic functions. So if you look, what we have here is, so looking at this table here, you can find this table for exponential functions on page 318 in your text. So these are all of the different types of transformations with respect to exponential functions. Please recall that the general term is like y equals a times it by b raised to the x power. So all of the characteristics of exponential growth and exponential decay remain the same as long as b is something larger than 1, it is a growth, and something that is when b is falls between 0 and 1, it is exponential decay. Now, if b is a negative number, that means that it is going to be flipped over um, on either the the x or y axis, depending on um, where the negative is located. So if you look at logarithmic functions, here are the transformations for this one. Remember that logarithmic functions are inverses of our exponential functions up top. And again, the general form is like y equals log base p of x. And again, this one can be found on page 320. Okay, so reference those when you are um, looking at describing these transformations. So for this one, it says they want us to describe the transformation of f of x equals 1/2 raised to the x power, um, represented by g of x equals 1/2 raised to the x power minus 4. Okay, so again, this particular one is like y equals b raised to the x power. In this case, b is 1/2. 1/2 is an exponential decay. So if I were to kind of graph this, so this would be like coming down like so, and this value right here would be what, 0, comma 1, and this value right here would be 1, comma 1/2. Okay. Now looking at this equation here, all right, it's still 1/2. The only difference is we have the minus 4 um, on the outside. So that means that it has no h, but it has a value of k, which is -4, which tells us that my graph is going to move 4 units down. So everything is going to move 4 units down. So it's going to be 1, 2, 3, 4. And same thing goes here. 1, 2. So, so let's see if I can 1, 2, 3, 4. So I'll just kind of move this down like so. And the one big thing that you have to recognize in this one, this graph here, my asymptote is at y equals 0. So now I have a new asymptote, and in this case, it comes from the translation. So my asymptote here would be like y equals, well, in this case, it would be -4 because it moved down 4 units. All right, looking at this one, it says describe the transformation of y equals e to the x power represented by g of x equals e to the x plus 3 plus 2, and then graph the function. So again, looking at this one, I'm just going to write it as y equals e raised to the x power. So looking at what we talked about with natural base, this particular example is an example of an exponential growth. So it would look something like so. And this one here would still be at 0, comma 1. This one here would be at like 1, comma e to the first. So it's like that 2.7. Okay. So that's where that comes in. If we look at this graph here, what they're telling us is we have a transformation with h being a -3 because it's always represented as the opposite appears for h, and then k is a +2. So we are going to move this graph um, 3 units to the left and 2 units up. So I just go, I gotta just take this one here. I'll just say 1, 2, 3, 1, 2, and it is the same graph as it is before. It's just translated to a different spot. Same thing goes here. The asymptote did change because it went 2 units up. My asymptote will be now y is equal to 2. So again, these are similar um, examples. My advice to you again is to refer to the transformation charts on the respective pages. And if you do have questions, please let me know. Looking at a logarithmic equation and asking us to graph the function. So for like this first one, it says I have f of x equals log of x. So yeah, I'm just going to write this as y. So y equals log of x. And then this one here is log of log of -1/2 x. So if I were to again graph this one, I mean, normally I would just put it into exponential form. So since there's nothing there, it's a base of 10 if you recall. So this is 10 to the y power equals x. So looking at this particular graph here, and so if I went -1, it would be, again, making a table. So I got my x1s and y1s. So this is 0, -1, 0, 1. 10 to the -1 is 0.1. This will be 1, and then this will be 10. So I got here, here, and then something right here. So it kind of looks something like this. So that is the first graph. Looking at the second graph, this one will appear as, so it looks like 10 to the y power is equal to -1/2 x. And you could multiply this by, or multiply it by -2, so it'd be like -2 to the 10 to the y is equal to x. and then kind of graph it from there. But when you're looking at the transformation of this, because of this negative 1/2, it is going to reflect over, in this case, the y-axis. And because I got the, um, because it's a value of 2 on the outside, it's actually a stretch of 2 because it's all absolute value. And in this particular graph, we will notice that because it's flipped, it'll look something kind of like this. Okay. And same idea. I'm not going to graph it, I'll just explain the transformation. So from here to here, because we have well, let me be clear about the stretch here. This is actually a horizontal stretch. Sorry about that. Sorry. Looking at the second example, so I got a 2 over here on the outside, and then I got this x plus 4 here. Because the 2 is on the outside, this then's a vertical stretch of 2. The other one's a horizontal. This is a vertical stretch of 2. And with x plus 4 inside there, that means that we have a value of h that equals negative 4. So my graph is going to move 4 units to the left. And looking at this very similar to the exponential functions, because we moved it to the left, that means that, so like, just by looking at the graph per se. So if I were to, just kind of give you a quick sketch of y equals log of 1/2 x, it would look something kind of like this. After you do, the math and stuff like that, and then with the translation of 4 units to the left, 1, 2, 3, 4, it would look something kind of like this. And what that changed is my asymptote is now would be like x equals negative 4. And that is being able to look at transformations of exponential and logarithmic functions. I hope this helps. Until next time.